Question 27b, Part 1. Find the perimeter of triangle PQR. Give your answer to one decimal place. The first thing to note is that triangle PQR is made up of two right-angled triangles joined back to back via a common side QS. In order to find the perimeter of triangle PQR, we need to find the length of side PS, which belongs to triangle PQS. But in order to do that, we need to find the length of QS, which is the common side of both of these right-angled triangles. And we can use triangle QSR since we know the length of QR and SR, and we know that triangle QSR is a right-angled triangle, to find the length of QS. So in triangle QSR, the hypotenuse is 5 centimeters. The length of SR, which is one of the short sides, is 4 centimeters. So using Pythagoras' theorem, QS squared is equal to 5 squared minus 4 squared, which equals 9. And to find the length of QS, we need to take the square root of 9. So the length of QS is 3 centimeters, and it's marked here in red. Now in triangle PQS, we know the hypotenuse of this right-angled triangle, 7 centimeters. We found the length of QS from triangle QSR, and that's 3 centimeters. So now we can find the length of PS, which is one of the short sides of this triangle. So in triangle PQS, using Pythagoras' theorem, PS squared is equal to 7 squared minus 3 squared. So PS squared is equal to 40, and taking the square root of 40 to find PS, PS is equal to the square root of 40. And we're going to leave it in surd form for now. I'll round at the very end. So the perimeter of triangle PQR is equal to 7 plus 5 plus 4 plus the square root of 40, which equals 22.3245 and so on, which rounds to 22.3 centimeters, correct to one decimal place. Part 2. Find the size of angle QPS to the nearest degree. In right-angled triangle PQS, I'm going to let theta represent the angle that we're trying to find the size of, which is angle QPS. Now note that the lengths of all three sides of this triangle are known. So we can use any two out of those three sides and regular right-angle trigonometry to find the size of angle theta. I'm going to use this side here, side QS, and this side here, side PQ. Now QS is the side opposite theta, and side PQ is the hypotenuse. Hence, sine theta is equal to opposite over hypotenuse, so that's 3 over 7. So in order to get theta on its own, we need to take the inverse sine of 3 over 7. So on the calculator, that's shift and then the sine button. So theta is equal to inverse sine of 3 over 7, which equals 25.3769 and so on degrees, which rounds to 25 degrees, correct to the nearest degree.